Hello, everyone. Today we'll be talking about deserts. As Lab 11, this is our final lab. Of course, only your top 10 grades will be taken. So if you're happy with your 10 previous lab grades, you don't have to do this one. You don't have to submit anything, and this will be the one you dropped. If you're not, make sure to do this lab so your lowest lab grade will be dropped. Logistically, I won't be able to hold my Wednesday Zoom office hours again this week. I'm really sorry about this, guys, but it seems like meetings keep getting scheduled here, and this time it's a dentist appointment. But my Tuesday office hours will still be on, and of course, if you can't make those and you have any questions, you can email me or you can reach out to me, and we can set up another time for a Zoom meeting. And then the last point for logistics, we have our lab final coming up next week. I'll be sending more information about that later this week, but make sure to keep an eye out for that and prepare however you feel you need to. All right, let's hop into the lab. We'll start with a PowerPoint on arid lands geomorphology. All right. Here's a photo of me in Wadi Rum in Jordan, which is an arid land. All right, so the first thing we're going to talk about is wind speed and frequency. So a wind rose is a circular chart that can be used to summarize wind regimes. It shows the frequency of winds blowing from a particular direction, and it also shows variability in wind directions at the site. You can see some examples of wind roses over here on the right. And wind roses can reveal changes in wind regimes between seasons as well. Next, we'll talk a little bit about aeolian erosion. So particles are initially mobilized in aeolian erosion and moved from the surface by deflation. And deflation is the removal of loose material by wind turbulence. It's important to know that clay particles are often cemented together, which usually would prevent them from being eroded by wind. And wind also usually can't move particles that are coarser than sand, such as pebbles. Now we'll talk a little bit about aeolian transportation and deposition. So once eroded, particles may travel by suspension. Suspension is when particles are carried with the airflow. And aeolian sand tends to travel nearer to the surface by traction and saltation. So traction is rolling and sliding, and saltation is jumping or bouncing. In general, materials are deposited where wind speeds decrease and lose kinetic energy. And now we'll switch over and talk a little bit about sand dunes. So with sand dunes, you can see here in this image on the right that there is a Strauss side and a slip face. So the Strauss side is the windward side of the dune. This is where sand grades tend to saltate up, as you can see in this image. And generally, these sides are eroded by wind. The slip face, on the other hand, is the lee side of the dune. You can see here and here, sand grades cascade down, and they can also be caught in these eddies of wind, which deposit them at the bottom. So slip faces are downwind, and they grow from the accretion of sand through those eddies and through the cascading of sand down. It's also important to know that dunes migrate downwind with erosion of the Strauss side and deposition of the slip face. And because erosion is compensated by deposition, the size and shape can often remain constant as the dune moves. In terms of types of sand dunes, unidirectional winds are associated with the most dune diversity. You can see some examples of unidirectional winds up here, and some of those include barchans or crescentic, barchanoid ridges and transverse dunes, parabolic dunes, and coastal blowouts. And you'll see some examples of these as you do the lab. In terms of non-unidirectional winds, bidirectional winds produce longitudinal dunes, like you see in this picture, where you have sort of these ridges and channels that go a long way. And multi-directional winds produce star dunes. as you see down here at the bottom. Here I am on Cerro Blanco, which is the tallest sand dune in the world. It's at the top of a mountain up in the Andes of Peru. And unrelated to that, in terms of spatial relationships of aeolian deposits, it's really important to know that grain sizes of aeolian materials tend to decrease downwind, and coarse material tends to lag behind, while finer materials carried further. Now we're going to switch gears and talk about fluvial processes in the deserts. As you all have discussed so far this semester, most rivers in the eastern United States are perennial. This means that they typically have water flowing in them year-round. And most of their water comes from smaller upstream water or groundwater. Runoff and other precipitation is generally supplemental to the water they're already receiving. But in arid locations, the water table may be hundreds of feet below the surface. And so many rivers in arid regions are intermittent or ephemeral. So what are intermittent streams? These are seasonal streams that flow only during certain times of the year. So maybe when smaller upstream waters are flowing and when groundwater provides enough water for the stream to flow. Again, runoff from rainfall or other precipitation supplements the flow of seasonal streams. And in dry periods, seasonal streams may not have flowing surface water. On the other hand, ephemeral streams or rain-dependent streams flow only after precipitation. So runoff from rainfall is the primary source of water for these streams, rather than being supplemental. And like seasonal streams, they can be found anywhere, but are most prevalent in arid areas. And lastly, we're going to talk a little bit about landforms shaped by water, specifically the alluvial fan, which we've talked about before. So alluvial fans are fan-shaped deposits of alluvium, or stream-deposited sediment. You can see an example over here on the right. Alluvial fans tend to develop where stream channels leave a canyon and broaden onto a wider plain due to sudden lateral mobility. You can see that sort of canyon and broadening onto a wider plain in this picture. And so these sorts of processes may build fans by repetitious shifting of the channel with deposited sediment raising the bed until the channel shifts again. And so you can sort of imagine that from this picture over here, that maybe a channel was flowing down here, and then eventually it had deposited enough sediment that that was no longer the easiest way to flow down. So maybe it switched, started flowing down here, and sort of so on and so on. And that's the way these alluvial fans get built up. So in arid regions where several alluvial fans along mountain front merge into a continuous apron of coalesced fans, the sloping surface of the combined fans is called a bajada or bajada. I'm honestly not sure, but it's called that. And alluvial fans occur in many different climates and in many different sizes. That's important to know. So that's all the general information we have for this lab. Let's hop over and just take a quick look at it. Like I said, we will be using Google Earth Pro, but it's all stuff you have already done before, so that shouldn't be a concern. So we'll take a quick look through the lab. Here you see some of the background that I went over. Again, more in depth, make sure to read through this so you get a deeper understanding. This goes over some of those types of sand dunes that I touched on but didn't really go into detail. You'll want to read through that before you do the lab and as you do it, because you're going to be identifying different types of sand dunes. Again, here's the fluvial processes with a little bit more information and some different examples. And then you're going to open up Google Earth Pro, and the first thing you're going to be taking a look at are arid landforms and sand dunes, first in Death Valley, California. So you'll go through these activities, sort of same old of what we've been doing. Again, there shouldn't be anything new that should be surprising or different in Google Earth Pro. And then the second activity is about the Nile River and looking at sort of changes in agriculture and water use in Egypt. Hopefully you'll all find it interesting. I actually put this part of the lab together myself. So if you don't like it, you can blame that on me. All right. So as always, you have a quiz for this week due at 11:59 p.m. this coming Sunday. Make sure to get that done. Make sure to do the whole lab. By now you've already watched this video. And as always, if you have any questions, have any concerns, please don't hesitate to reach out to me. All right. Thank you all, and I hope you have a great week.